So now I'm going to solve like exercise 5, question number 25. But before going on to the problem, I'd like to discuss the internal section formula. So internal section formula is not official in the Cambridge syllabus, but you can use it, no problem. And in this sum, actually, if you use it, actually, it's quite helpful. And I actually saw in a very old paper, Cambridge paper also, if you use the internal section formula, the sum becomes easier. But you can do the sum even without the internal section formula. I'll show that also. Now, what is the internal section formula? This is, let's say you have a line A. So internal section formula, it actually means dividing a line internally into a given ratio. Okay, so let's say you have a point, if a line segment AB, and you have a point M somewhere over here. By M, I don't mean the midpoint. By M here, I don't mean the midpoint. Let's say you divide this, M divides this line AB in the ratio M is to N. Small m is to small m. Okay. In the class, I use the ratio lambda mu. I use the notation. So same, you can use m and n also. So let's say the coordinates of A are x1 and y1. Coordinates of B are x2 and y2. And the coordinates of C are x3 and y3. So m is to n means, let's say, in what ratio it divides, like 2:3, 2:5, 5:2, 1:1. If 1:1, then actually m is the midpoint. It divides into two equal parts, then m is the midpoint. So the formula goes like this. So your this x3 is going to be, it's very easy to remember because it's just like a cross multiplication. So m into x2 plus n into x1 divided by m plus n. And y3, it is m into y2 plus n into y1 divided by m plus n. So this is the formula. And notice that if m is the midpoint, then m is to n is basically 1:1. It is basically 1:1. If m is the midpoint, then it is m and n are 1 and 1. Like it divides into two equal parts. In that case, this formula just becomes the formula for finding the midpoint. x2 plus x1 divided by 1 plus 1, 2. x2 plus x1 divided by 2. y2 plus y1 divided by 2. If it is the midpoint, that is the ratio will be 1:1, then this formula just becomes the formula for the midpoint. This becomes the formula for finding the midpoint. Okay. Let's look at a small example using this formula, so it will be more clear to you. A and B, the coordinates are -1, 5, and B is 3, 9. So there is a point C which divides AB in the ratio 1:3. Okay, something like this. I'm not drawing the coordinates accurately. Let's say C is here. It divides in the ratio 1:3. So what are the coordinates of C? So the x coordinate of C is going to be basically, so 1 into 3 plus 3 into -1 divided by 1 plus 3. Whatever you get over here. And the y coordinate of C is going to be 1 into 9 plus 3 into 5 divided by 1 plus 3. So you can actually figure it out. Okay. Just I wanted to give you some practice with the internal section formula. Now I'll move on to the main sum. That is question number 25. I actually assume that you have the book in front of you. Okay. So I drew the diagram, but still you should have the book in front of you because I didn't write the coordinates. Okay. So basically what, here you have the point M, which bisects the line AC, line segment AC. Okay. And BD is actually a perpendicular bisector of AC. Like BD and AC, they are perpendicular, and also N is the midpoint of AC. All right. So first they're asking for what? Find the equation of BD. Find the equation of BD. If you look in the book, actually they have given the coordinates of AC, but we don't know the coordinates of B. We don't know the coordinates of D also. Okay. But realize that this midpoint, it does lie on the line BD. This midpoint of ACM, it lies on the line BD. The midpoint of ACM lies on the line BD. So if I find the midpoint of AC, I know a point on the line BD. And AC and BD are perpendicular to each other. So I know the coordinates of AC. I can find the gradient of AC, and from there I can find the gradient of BD also. In the process, I can actually find the equation of BD because I know a point M and I know the gradient, which is the negative reciprocal of the gradient of AC. So the coordinates of M are going to be, so just x1 plus x2 by 2, y1 plus y2 by 2. You'll get 7 by 2 and okay, I'm not showing the details because you already know it. And the coordinates of A and C are given. And the gradient of AC, it is minus 2 by 5. Minus 2 by 5. So the gradient of BD will be what? Gradient of BD, it is 5 by 2. It is 5 by 2. So the equation of BD, so I know the point, I need to know the point and the gradient of the line. So point is not neither B nor D. The point is M. M lies on BD. And the gradient is 5 by 2. So y minus 2 is equal to 5 by 2 into x minus 7 by 2. Okay. So if I simplify this, I actually get this equation ultimately. 4y is equal to 10x minus 27. This is the equation of B. This is the equation of B. All right. Now, you have to understand. Now they're asking for the x coordinate of B. They're asking for the x coordinate of B. So B lies on the x-axis. That means the value of y, the y coordinate is going to be what? 0. Since B lies on the x-axis, the y coordinate is going to be 0. So if I put 0 over here, so 10x minus 27 is equal to 4 into 0, 0. So x is equal to 27 by 10, 2%. So the coordinates of B are 2.7 and 0. That's the coordinates of B. So B lies on the line BD definitely. So, and it lies on the x-axis. So the value of y is 0. So if I put the value of y over here, I get the value of x. I get the value of x. Okay. Now the tricky part actually, the part that has caused a lot of the trouble, that is find the coordinates of this. This is the most tricky part of this question. So first, I'm going to show how you can do this using the internal section formula, which is the easiest way to do this. Then I'm also going to show, let's say you don't want to use that formula, how you can do that also. How you can do that also. That method is not difficult, but rather it's very lengthy. It becomes too much manipulative. Okay. Here it is given that BD is equal to 7 by 2 BM. That means your BM by BD is equal to 2 by 7. BM by BD is equal to 2 by 7. So what is the ratio of BM and MD? That is your how the line M divides the line segment BD. Okay. So BM is to BD, it is 2 by 7. So that means what? That means if this section is 2, if BM is 2, or let's say BM is 2x, then your BD is 7x. Then what is the length of MD? Just 7x minus 2x, it will be 5x. Let me repeat. So BM is 2 BD. According to the question, just I'm rearranging this. It is 2:7, 2 by 7. That means here, if BM is 2x units, I can just write 2 also. It is not 2 units, but just the ratio actually. So if the BM is 2x units, then your BD is 7 units. So what is MD? It is 5x. So your BM by MD, it is actually 2 by 5. Is actually going to be 2 by 5. Okay. So now actually just, so if I use it, so it is actually 2:5. This is 2:5. Okay. So what are the coordinates of, so we know the coordinates of M actually. So let's say I take the coordinates of D as x1, y. So basically what? 5 into the x coordinate of B, that is 2.7, plus 2 into the x coordinate of D, that is, let's say I'm taking as x1, divided by 2 plus 5 is equal to the x coordinate of M, which is 7 by 2. From here, actually, I get x1 is equal to 11 by 2. X1 is equal to 11 by. Okay. So basically 5 into x coordinate of b plus 2 into x coordinate of d, which I'm taking as x1, divided by 2 plus 5 is equal to the x coordinate of m. M is dividing bd in the ratio 2:5. I'm going to do the same for the y coordinate also. I'm going to do the same for the finding the y coordinate also. So 5 into the y coordinate of b, which is what? 0, plus 2 into the y coordinate of d, which I'm taking as y1, divided by 2 plus 5 is equal to the y coordinate of m, which is 7. Sorry, y, which is y coordinate of m, which is 2. From here, I get y1 is equal to, that is the x coordinate of, the y coordinate of d, that is 7. Okay. So the coordinates of d are what? So I get the coordinates of d as 11 by 2, 7. 11 by 2, 7. That's the coordinates of d. So that's I can find quite easily using the internal section formula. All right. So in this case, actually, this is the easier way to do it. In this case, this is the easier way to do this sum. Now, let's say, I'm showing it that you want to do it even without using the internal section formula. So I need two equations actually, so that I can solve simultaneously and find the gradient, again, find the coordinates of d. So you have one relationship over here. BD is equal to 7 by 2 BM. So let's say I take the coordinates of D as x1 and y1. So we know the coordinates of B, and we also know the coordinates of M. So I can just use the distance formula. So root x1 minus 2.7 whole square plus y1 minus 0, so y1 square, is equal to 7 by 2 into root Bm will be what? Bm is going to be, so root 7 by 2 minus 2.7. So Bm. So just using the coordinates of Bn. So 7 by 2 minus 2.7. And then 2 minus 0. That is 2 square. Okay. Just using the distance formula. So actually, it's better to, I have to square it. Actually, I have to square it. So I get x1 minus 2.7 whole square plus y1 square is equal to 49 by 4. So you can actually evaluate this whole, so it's going to be, all right. So you can actually, so this one equation that you have, this is one of the equation that you have. I get this by using this information that is given. Since I know the coordinates of B and M also. Okay, I use the like the distance formula, how to find the distance between 2 points. But now I need some other equation. So some other equation how I can find. So I know that BD lies on the line, D lies on the line BD, definitely. So obviously x1 and y1, they are going to satisfy the equation of BD. The coordinates of D are going to satisfy the equation of it's going to satisfy the equation of BD. So let me just insert x1, y1 over there. So I have 4y1 is equal to 10x1 minus 27. So this is another equation. So I can use the method of substitution. For example, I can write y1 is equal to 10x1 minus 27 by 4. Then insert y1 over here. And then solve it to find the value of y1. And then from, solve it to find the value of x1. Then from there, I can get the value of y1 also. Basically, I get two equations. One from the distance, another from the fact that BD lies on the line. That is, the point D lies on the line BD. So two equations I just have to solve simultaneously. But this is, the manipulation can be a bit lengthy, but you'll actually eventually get the same answer. You'll actually eventually get the same answer, but this method is much more lengthy. This method is actually much more lengthy. In the next section, they're asking you to find the area of quadrilateral ABCD, that is 25B. Area ABCD. Quadrilateral ABCD. So I can easily use the shoestring method. It is possible to do even without the shoestring method because this is right angle. So half AC into BM plus half AC into MD. And I encourage you to do using that also, like practice. Like the ABCD, the quadrilateral is basically what? Two triangles. So triangle ABC and triangle ACD. So half, this is right angle. So half AC into BM plus half AC into MD. Okay, do that and see if you get the same answer. Now, but very convenient if the coordinates are known to use the shoestring method. So actually, this is how we actually applied the determinant sign. So I'll write the coordinates in anti-clockwise fashion. Okay. If I write the coordinates in clockwise fashion, I'll get the same value, but the answer will come as negative. Okay. But the problem is if I write the coordinates in such a way that is neither clockwise nor anti-clockwise. For example, here if I write ACBD, it is neither clockwise nor anti-clockwise. So I'm writing the code, taking the coordinates as ABCD. It is actually clockwise. So I should get the correct answer, but negative. So A, coordinates of A, B, C, then D. D actually we have found out already. And then whatever I started off with the coordinates of A. I have to write that in. So this is how I'm going to proceed. Half. So in this way. So 6 into 0 plus 2.7 into 3 plus 1 into 7 plus 5.5 into 1. 20.6. Minus, then I'll go in the other way. So 6 into 7 plus 5. 6 into 7 plus 5.5 into 3 plus 2.7 into 1. So minus 61.2. The answer I get is minus 20.3. So actually the area will be what? 20.3 units square. The area is going to be 20.3 units square. I know from before the lecture I understood that because the diagram is given that since that coordinates are being taken in clockwise fashion, the answer you're going to get is a negative. Okay. So 20.3 units square. That's going to be the area of triangle, sorry, quadrilateral ABC. Okay. In the next part, they're actually asking you to find the perpendicular distance from D to BA extended. That is, the perpendicular distance from D to BA even extended. So they're asking for this height. BA extended from D, you're going to draw a perpendicular here. Since if I draw a line here, none of them are perpendicular, so I have to extend it, and this is the perpendicular distance from D to AB. Okay. So for doing this, we know that area of triangle ABD is going to be half base into height. So if I take the base as AB, this is going to be the height. So first, let me find the area of triangle ABD. Okay. So let me use the shoestring method again. Let me use the shoestring method. Even I can find it without using the shoestring method, but for example, half DM is to AM because this is perpendicular to this. So half base into height. I can use that method also. But let me use the shoestring here. Half. So let me take the triangle. Let me take the coordinates in the. So in this way, ADB, AD, and B. Okay, in this way. So this is anti-clockwise actually. This is anti-clockwise. So now I should get the answer as positive. ADB. So A is 6.1, D is 5.57, B is 2.70, and then I have to write A again, whatever I started off with. So this area, what you're going to get, so this is again, you'll do in the same way, half 6 into 7 plus 5.5 into 0 plus 2.7 into 1. This is 44.7 minus 6 into 0 plus 2.7 into 7 plus 5.5 into 1. This is 24.4. So the area is 10.15 units square. Area of triangle. Area of triangle ABD. Now, so in order to find this height, so half AB into this perpendicular distance from D to AB, that's what they're looking for, is equal to this area, 10.15. So what is the length of AB? Actually, what is the length of AB? I can easily find. Like this is the coordinates of A, this is the coordinates of B. So 6 minus 5.5 whole square plus 7 minus 1 whole square, square root. AB, this is actually the coordinates of D. So I took here as ADB. Okay, so this is the coordinates of D. So AB, so this is A, this is actually the coordinates of D. So 6 minus 2.7 whole square plus 1 minus 0 whole square. It is square root. I get 3.448 or basically root 11.89 into H is equal to 10.15. So your H, there's a perpendicular distance from D to AB is going to be 0.15 into 2, 10.15 into 2 divided by root 11.89. So this counts as 5.89. This counts as 5.89 units. This is a half base into height. Use that concept, and we have done this in the previous sums also already. Okay. For example, in question number 22, this technique has been applied.